Hi everybody and welcome to another Sensirion SFM flow sensor video. My name is Lucas and I'm a contact partner for medical customers. In this video, we'll have a look at how to successfully perform first tests with flow sensors and what to pay attention to. For this purpose, I've prepared the following test setup. We'll use pressurized air from this gas bottle and regulate flow with Sensirion's SFC 5500 mass flow controller. Downstream, we have the flow sensor which we want to test. I have here an SFM 3003 flow sensor. But you can use any of Sensirion's inspiratory, expiratory or proximal gas flow sensors in this setup. A great overview and lots of additional information can be found on sensirion.com/vents. I'll leave a link in the description below. After the flow sensor, we use a Cytrex H5 device from IMT Analytics as our reference to verify the accuracy of the flow sensor. To connect these different devices, we like to work with medical breathing tubes, which allow easy and leak-tight connections. It is important to always compare flows at the same standard condition. Sensirion's flow meters output a flow in standard liters per minute, which is defined as the volume flow at ambient conditions of 1013 millibar and 20 degrees Celsius. On a Cytrex H5 device, this corresponds to the setting 20/1013, which we'll select now. Now, with everything connected, we're ready to start the actual test by opening the gas bottle to build up the pressure in our mass flow controller. Nothing is happening yet, as the flow is currently set to 0 and the valve is still fully closed. What would you expect to happen if I enter a set point of 70 liters per minute in our control software? Well, the accuracy of the mass flow controller is specified at ±1%, and the accuracies of the reference, the Cytrex H5, and our flow sensor are both around 3% of the measured value. That means, for a set point of 70 liters, I would expect the two flow sensors to show measurement values between 67.2 and 72.8 liters per minute. Let's see what happens and start the measurement by entering 70 liters per minute. The first thing we can observe, or rather hear, is the setup is very noisy, which is an indication for turbulences. Indeed, any proportional valve creates jets with lots of energy. These jets and turbulences make an accurate flow measurement very challenging. But let us see what we get. The flow sensor shows roughly 68 liters per minute, and the reference is showing us 68.0 liters per minute. Indeed, we see that both readings are deviating from the set point of 70 and are close to the lower limit of 67.2. So let us stop the measurement. We see that even this straight metallic pipe with meshes inside to get good inlet condition is not sufficient to remove these turbulences, as the reference itself is also deviating. To get the best performance, such turbulences need to be calmed. This can be achieved by adding resistance to the flow to remove the kinetic energy from the gas. In our lab setup, I will add a medical filter which works very well. With this improved setup, let us repeat the test and set a flow of 70 liters per minute. What can you hear? Yes, there is less noise now. This is a good sign that the jets and turbulences have been removed, and I'm very curious to see what you get with these laminar flow conditions. Indeed, I get 69.7 liters per minute from the flow sensor and 69.1 liter per minute from the reference. Both values are very close to 70 liters per minute and well within the tolerance range of 67.2 and 72.8 liters per minute. That's great, we have an accurate reading at 70 liters per minute. In a real setup, and when evaluating prototype designs of your ventilator, it is very important to verify the behavior across the entire flow range. So let us repeat this measurement at 10 liters per minute, for example. With the same explanation as before, I would expect the flow sensors to read anywhere between 9.6 and 10.4 liters per minute. Is this also what we'll get? Yes, we're spot on! The reference is showing 10.0 liters per minute, and also the flow sensor is indicating 10.1 liters per minute. This means that we now have a setup with no turbulences affecting the sensors and an accurate flow reading over the entire flow range. Now I encourage you to conduct this experiment in your lab. When starting your tests, we recommend to begin with a simple setup as this one and then add complexity in later steps, one by one. Evaluation kits for our flow sensors including the cables, and for the mass flow controller SFC 5500, which I'm using here, can be ordered directly from our online distribution partners. Check out our engineering guide, which provides lots of additional information for testing and designing. Thanks for watching and hope to see you in one of the next videos. Happy testing!